All right, section 9.2, we're talking about sum and difference identities. Okay, so for cosine, the sum and difference formulas would be this right here. If you have two angles that are adding together and you have cosine, then what you're going to have is cosine of that first angle times cosine of the second angle minus sine of that first angle times sine of the second angle. But if you have two angles that are subtracted from each other and a cosine, then you'll have cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. And just a note, notice if we're adding, we have a subtraction sign here. Whereas if we're subtracting, we have an addition sign here, so they're backwards. So if we look at cosine of 15 degrees, what we're trying to do is we're trying to break this angle up into angles that we already know how to solve. Basically, our special triangles and our quadrantal angles. So this list right here, that's what we're trying to work with. And later we'll work with reference angles as well. But for right now, if I'm just going to pick two angles that I know how to work with, subtract them to give me 15. So say I do cosine of, so 15 is equal to cosine of 45 minus 30. Now you can also do 60 minus 45. That would also work. Now since we have two angles that are being subtracted, we need to use this formula right here. So this will boil down to cosine of 15 is equal to cosine of 45 times cosine of 30 plus sine of 45 times sine of 30. Now we need to go through each one of these and find cosine of 45, cosine 30, and sine of 45 and sine of 30, which means we'll need two special triangles. We'll look at 45 first. So across the 45s we have 1, and for the hypotenuse we have the square root of 2. So cosine of 45, we know that's x over r. Our x is 1, our r is square root of 2. Rationalize that. Square 2 over 2. Okay, so there is cosine of 45. And then sine of 45 will be y over r. This will be 1 over square root of 2, same thing. We need to rationalize that. So square root of 2 over 2 as well. I'm going to leave a blank for this one. This will be square root of 2 over 2, and a blank for this one. Now remember, if you've got cosine and sine together, let me move this. And if this angle plus this angle equals 90, they're going to equal the same thing. So because these are 45 and 45 plus 45 equals 90, well, they should come out to the exact same answer. That's just an FYI at this point. Okay, and then let's go back and find special triangles using 30. Okay, so for 30, this will be 60. So across from 60, square root of 3. Across from 30 is 1, and across from the on the hypotenuse in the 30, 60, 90 triangle is 2. So cosine of 30, x over r, square root of 3 over 2. So this one is square root of 3 over 2. Sine of 30 is y over r, or 1/2. Okay, last thing to do is to multiply these together. Square root of 2 times the square root of 3. Well, that's going to be the square root of 2 times 3, or 6, over 2 times 2, which is 4, plus the square root of 2 times 1, just itself, times 2 times 2, is 4. Okay, well, I'm going to, since they have the same denominator, this is the square root of 6 plus the square root of 2 all over 4. And because this is addition, you could switch them up. Square root of 2 plus the square root of 6 over 4. It's the same exact thing, but that would be your final answer for cosine of 15. Now I want to show you cosine of 15 using 60 and 45 to show you that it will come out to the exact same thing. So cosine of 15 is equal to cosine of 60 minus 45. Okay, so cosine of 60 times cosine of 45 plus sine of 60 times sine of 45. And I'm just using this formula again because we have cosine and we have two angles subtracted from each other. Okay, so I need, again, 2, and actually, we already know what cosine of 45 is. We just found that. Square root of 2 over 2. And we know what sine of 45 is. Square root of 2 over 2. So let's look at 60. So cosine of 60, x over r, our x is 1 over 2. Sine of 60, y over r, square root of 3 over 2. Okay, 1 times square root of 2, square root of 2. 2 times 2 is 4. Square root of 3 times square root of 2 is the square root of 3 times 2, or 6. 2 times 2 is 4. Have the same denominator. So it'll be square root of 2 plus the square root of 6 all over 4. And I mentioned over here that you can switch these two, actually the top numbers. It doesn't matter because it's addition, so you're not changing anything. So there's our answer. As long as the two numbers that you pick, as long as when you subtract them it comes out to what you're looking for, it doesn't matter what the numbers are, it's going to come out to the same answer. So let's look at cosine of 105. So 105. Say I take cosine of 60 plus 45. That's the same thing as 105. So then what I need to use is this formula, cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. So what this is going to equal to is cosine of 60, cosine of 45, minus sine of 60, sine of 45. And I'm going to leave blanks for these. We already know sine and cosine of 45, so we'll just go ahead and write those in. And we also already know cosine of 60 and sine of 60. We found that over here. Cosine of 60 was a half, and then sine of 60 was the square root of 3 over 2. Okay, so if I multiply this out, I get the square root of 2 over 4 minus the square root of 6 over 4, which is square root of 2 minus the square root of 6 all over 4. Now for this one, I can't change it to this right here because it changes your answer. Okay, so this right here is our final answer for that one. And then let's look at this right here. Now before we start plugging in numbers, recall this right here, cosine of negative theta. Remember, this is an even function, so it's like the negative just disappears. So really that's just cosine of theta. So what it's saying is cosine of negative 105 is really the same thing as cosine of 105. And we just found 105 degrees for cosine. That was the square root of 2 minus square root of 6 over 4. So since these two are equal, that means the cosine of negative 105 is equal to the square root of 2 minus the square root of 6 all over 4. And then we'll look at the sum and difference for sine. So if I have sine and two angles being added together, it's going to be sine of the first angle times cosine of the second plus cosine of the first times sine of the second. But if I have two angles being subtracted from one another, I'll have sine of the first times cosine of the second minus cosine of the first times sine of the second angle. Notice if we're adding here, we're adding here. We're subtracting here, we're subtracting here. And these are alternates. You got sine then a cosine, cosine then a sine. Whereas back here for cosine, they were both the same. Okay, so let's look at find the exact value of sine of 75. Okay, so sine of 75, I can break that up into sine of 45 plus 30. So then I have sine of alpha plus beta is equal to sine of alpha cosine of beta plus cosine of alpha sine of beta. So this would be equal to sine of 45 times cosine of 30 plus cosine of 45 times sine of 30. So again, we know what sine of 45 is, square root of 2 over 2. And we know cosine of 45, square root of 2 over 2. Sine and cosine of 30, we found that over here. A cosine of 30 is square root of 3 over 2, and sine of 30 is 1/2. So we'll plug that back in over here. So this was the square root of 3 over 2, and this is 1/2. So now we have square root of 6 over 4 plus square root of 2 over 4. So square root of 6 plus square root of 2 all over 4. And that's going to be our final answer. Notice how all these are looking pretty much the same, using the same numbers here. And then let's look at sine of 15. So we'll have sine of 15 is equal to, now you can use 45 minus 30, or you can use 60 minus 45. Either one is going to come out to the same thing. Here, I'm going to use 45 minus 30. So I'm going to have sine of 45 times cosine of 30 minus cosine of 45 times sine of 30. Okay, so get blank for each one of these. We already know that sine and cosine of 45 square root of 2 over 2. We just said that cosine of 30 is square root of 3 over 2, and sine of 30 is 1/2. So this is square root of 6 over 4 minus square root of 2 over 4. And that is square root of 6 minus the square root of 2 all over 4. That'll be our final answer. Okay, now we're going to use reference angles to help us use our special triangles in these situations. And this is just a summary for each quadrant. Here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You don't have to memorize these. You can use the equations that we use back in, I believe, chapter 7 to find these. But this is just a rough guide to kind of go back to for this section for right now.